Hello, everyone, and welcome to Math Unpacked. Today, we're going to look at 3 examples of how to solve linear equations in one variable. Enjoy. So, the first equation we're going to solve is this 5x minus 2 equals 3 for x. The first thing we want to do is write down, let's write down the equation again here. 5x minus 2 equals 3. The strategy for solving these kind of equations is collect all the terms on one side of the equation, and for these examples I'm going to be collecting everything on the left-hand side of the equation. Then we're going to isolate the x variable by moving all the constant terms to the other side, and then finally we're going to divide out by any overall factors of x. Also, you could run into more complicated examples where you have parentheses that you need to multiply out first. So that's always going to be the first step. But in this case, everything is sort of already multiplied out and we just need to collect everything. So we'll do this simpler example first and then move on to some more complicated examples. So we have this equation here. So the first thing we want to do is collect all the terms on one side of the equation. Here we have a 3 sitting on the right-hand side, and we have the rest of the terms sort of sitting over here on the left-hand side. So we want to move the 3 over together with the rest of the terms. So the way we do this is we subtract 3 from both sides of the equation. So I'll draw arrows here to indicate that I'm doing some sort of operation on the equation itself. So remember, we can always add or subtract anything from both sides of the equation, and that'll still make the equation hold true. So we can subtract 3 from both sides of the equation here, giving us, so we still have 5x minus 2, but then we also subtract 3 from both sides of the equation here. So on the left-hand side, we subtract 3, and then we have 3 over here, and we subtract 3 as well. 3 minus 3 is going to cancel and give us 0. While on the other side of the equation here, we have still 5x, and then we have minus 2 minus 3, which is going to give us minus 5. Okay, so that's going to be after collecting sort of everything on the one side. So we're gonna want 0 on one side of the equation and the rest of the terms on the other side. Now we want to move all the constant terms to the other side of the equation. So in this case, we want to move the minus 5 over to the other side of the equation, which means that we're going to add 5 to both sides of the equation. So we still have 5x here, and then we have the minus 5, and then we add 5 to both sides of the equation. So 0 plus 5 is going to give us 5, and then we have this minus 5 and the plus 5 that are going to cancel out. So we're going to be left with just 5x on the left-hand side and a 5 plus 5 on the right-hand side. Now to get to x, we have a pesky 5 sitting in front of the x, so we want to divide both sides by this 5, so the overall factor that's sitting in front of the x. Okay, so we want to take both sides of the equation. This is also something you can do. You can always divide both sides of the equation by some amount, or multiply both sides of the equation, and then the equation will still hold true. So if we divide both sides of the equation by 5, the equation will still be true. Dividing by 5 here. Now 5 divided by 5 is just going to give us a 1. So on the left-hand side, we're going to have 1 times x left over after dividing the 5 and the 5. And on the right-hand side, we're going to have 5 divided by 5, which is just going to be a 1. So the solution to this equation is x equals 1. Now, We also want to check whether our solution is true because we might have made some mistake along the way of solving the equation. So the way that we check whether the solution is true is by plugging the solution back into the original equation and then checking if we get a true equation out of it. So a true equation is something like 1 equals 1 or 3 equals 3. So let's go back to the original equation here. The original equation was 5x minus 2 equals 3. So let's write that here. 5x minus 2 equals 3. If we plug in x equals 1 here, we're going to have, instead of 5 times x, we're going to have 5 times 1, which is just going to give us a
5.
So if we simplify both sides, we're going to have 5 minus 2, which is going to give us a 3 on the left-hand side, and the right-hand side is also a 3. We end up with a true equation. True, which allows us to evaluate that the solution is correct. Okay, so that's the strategy here for solving this equation. Now we're going to move on to the next example, which is going to be a slightly more complicated equation. We're going to solve 5x minus 2 equals 3x. So now there's an x sitting on the right-hand side. So let's write down the equation that we want to solve. 5x minus 2 equals 3x. Now we do the same procedure as before. We want to collect everything on one side of the equation. And then we isolate x from there. We start with subtracting 3x from both sides of the equation to get rid of everything on the right-hand side. So we still have the original 5x minus 2, and then we subtract 3x from both sides. And then on the right-hand side, we have 3x and then minus 3x. So here we've subtracted from both sides 3x. On the right-hand side, we have 3x minus 3x, which is going to give us 0. And on the left-hand side, we're going to have a 5x and a minus 3x. So that's essentially 5 minus 3, which is going to give us 2. So there's a 2x left over here and a minus 2. So the left-hand side is now 2x minus 2, and then equals 0 on the right-hand side. Okay, so now we have this 2x minus 2, so we can move the constant terms over to the other side. So we want to add, in this case, 2 to each side to get rid of the minus 2. So we're going to have 2x minus 2, this is the original. Then we add 2. And then on the other side, we also want to add 2. So adding 2 to 0 is going to give us 2. On the left-hand side, we're going to have a minus 2 and a plus 2, which are going to cancel, like that. And we're going to be left with 2x equals 2. Okay? And we do the same trick now as we did before. We divide by the factor that's sitting in front of the x, which is 2. So we divide both sides of the equation with a 2. So we have 2x divided by 2 equals 2 divided by 2. So divide both sides by 2. Now we're going to have the 2 divided by 2 is just going to give us 1. So we're going to be left with just 1 times x, or just x on the left-hand side. And then on the right-hand side, we're going to have 2 divided by 2, which is going to give us a 1. So that is the solution to the equation. Again, we want to check whether or not this is a correct solution. So we plug it back in. Let's go back and check here. The original equation was 5x minus 2 equals 3x. So let us write that here. 5x minus 2 equals 3x. And let's plug in x is equal to 1 here. So we're going to have 5 times 1 minus 2 is equal to 3. Oh, 3 times 1. Simplifying both sides, we're going to have 5 minus 2, which is going to give us a 3. And we're going to be left with a 3 on the other side. So we're going to have here a true equation after plugging in the solution. So we can conclude that the solution is correct. Now let's look at the last problem that we're going to solve, which is a slightly more funny looking problem. It's going to be solving this equation 5 parentheses t minus 1 equals 2t plus 4. And we want to solve it for t now. Now note that the variable is called t and not x anymore. It doesn't have to be called x. It can be called t, it can be called y, a, or whatever name you desire. So now let's try to solve this equation. So let's first write down the equation that we want to solve here. 5 parentheses t minus 1 equals 2t plus 4. Okay? This is slightly more complicated than the previous two examples because we now have this parenthesis t minus 1 sitting here. The first thing we want to do in this case is to get rid of the parenthesis. So multiply the 5 into the parenthesis. So the way we do this is we multiply, in this case, the 5 with each term in the parenthesis. So the way this works is we're going to get 5 multiplied by t, which is going to give us 5t. And then we're going to have 5 multiplied by minus 1, which is going to give us minus 5. Okay? And the right-hand side is the same as above. We are not doing anything with that right now. Okay? Now we can go on and collect everything on one side of the equation. So we first want to get rid of the 2t that's sitting on the right-hand side, which we can by subtracting 2t from both sides of the equation. So let's see here. So the left-hand side of the equation is still 5t minus 5. So that's the original, stays there. And then we subtract 2t. And on the right-hand side, we also still have the original. And we subtract 2t from there as well. Okay? Now we want to simplify, and on the right-hand side, we have 2t and minus 2t canceling each other. So 2t minus 2t gives 0. So we're left with a 4 that's sitting on the right-hand side. And on the left-hand side, we have 5t and minus 2t. So that's going to give us 5 minus 2t. That's the way when you have something t and then plus something else t, you can put the prefactors, so the factors that's sitting in front of the t, into a parenthesis that then add up in certain ways. So in this case, we're going to have 5 minus 2t, which is going to give us just 3. Oh, that was 3t. Yep. And then we still have the minus 5 that's sitting here. Okay? So let me write that down here. 3t minus 5 equals 4. So that's the equation that we're at right now. 3t minus 5 equals 4. Now we want to move the 4 that's sitting on the right-hand side over to the left-hand side. So the way we do this is we subtract 4 from both sides of the equation. Okay? So we have the original here sitting on the right-hand side, and we subtract 4. And on the left-hand side, we also have the original 4 sitting, and we subtract 4. So now we've taken the equation and subtracted 4 on both sides. So let's simplify now. On the right-hand side, we have a plus 4 and a minus 4, and they cancel to give 0. On the
left-hand
side, we have this still the 3t sitting, but then we have a minus 5 minus 4, which is going to combine to minus 9. So we have 3t minus 9 equals 0. Okay, now we want to move the constant term, this minus 9, over to the right-hand side. So the way we do that is by adding 9 to both sides. Okay, so we have 3t minus 9, which is the original on the left-hand side, and then we add 9, and then it's equal to 0 plus 9 on the right-hand side, so it's also adding 9 to the right-hand side. So let's simplify. So we have 3t, and then we have minus 9 plus 9, which is going to give us 0, so they cancel. And then we have equal to plus 9 on the right-hand side. Okay. Now finally we want to divide by the factor that's sitting in front of the t, which is in this case is 3. So we want to divide both sides by 3 in order to isolate the t that we want to solve for. Okay. So so now we've taken the 3t divided by 3 and the 9 that's sitting on the right-hand side and divided by 3. So let's simplify this. The 3t divided by 3 is just going to give us t, because 3 divided by 3 is just going to be 1, so it's 1 times t. So we're just going to have t, which is the same as 1t. And then on the right-hand side, we're going to have 9 divided by 3, which is going to give us 3. So that's the solution to the equation. T is equal to 3. Okay, so let's go back and check the solution with the original equation. So the original equation was 5t minus 1 is equal to 2t plus 4. So we plug in the solution to the original equation and check whether or not we get a true equation out of it. Okay, so let's write here 5t minus 1 is equal to 2t plus 4. Okay, so we plug in the solution. So let's get rid of this t here. So we have, instead of t, we plug in t equals 3. And then for t, we plug in t is equal to 3. So we now have to simplify this expression. The first thing we can do is evaluate the parenthesis. So this parenthesis here is going to be 3 minus 1, which is going to give us 2. So we have a 5 times 2 on the left-hand side. And then over here on the right-hand side, we have 2 times 3, which is going to give us 6. And then plus 4. And then finally, we can evaluate the rest of the multiplication on the left-hand side and the addition on the right-hand side. So on the left-hand side here, we have 5 times 2, which is going to give us 10. And on the right-hand side, we have 6 plus 4, which is going to give us 10. So 10 is equal to 10 is certainly true. So this is a true equation. So we conclude that the solution is correct. And that was 3 examples of how to solve linear equations in one variable. I hope you enjoyed the video. Like and subscribe, and I'll see you in the next one for more Math Unpacked.